In this question, we've been told that a particle P of mass 2 kilograms is moving under the action of a single force F. At time t, the velocity of P is v. When t equals 0, v equals negative 3i plus j, and when t equals 4, v equals 5i plus 5j. Now, when t equals 0, we know that's the beginning of the journey, so that's the initial velocity. So really, it's u that equals negative 3i plus j. So first we're asked to find, in degrees, the bearing of the direction of motion of P when t equals 0. So that's the initial velocity that we're looking for. The velocity indicates the direction of motion. So the initial direction of motion is negative 3i plus j, or negative 3, 1. And the best thing to do here, as always, is to get a diagram. Let's see what this vector looks like. Here's our starting point. We move 3 to the left and up by 1. This is the vector. We can use all the information here to find out what theta is, and that will be useful to know. So theta is inverse tan 1 over 3. That gets us 18.43 degrees. That's not exactly what the question wants from us, though. The question wants us to find the bearing, and the bearing needs to start from north and go clockwise. So 3/4 of a turn get us to the horizontal dashed line. 3/4 of a turn is 270 degrees, and we're going to add theta onto that. 270 plus our theta, 288.43 degrees. In part B, we're asked to calculate the magnitude of F. We have a lot of information here. We have an initial velocity, a final velocity, the time that it took. That information only links to F, the force that's unknown, through one variable, through acceleration. So we can use our constant acceleration SUVAT formulae to try and find acceleration, and then use that acceleration over in Newton's second law to find F. Okay, let's go. Collecting SUVAT variables, the initial velocity is negative 3, 1. The final velocity is 5, 5. The time it took to change velocity, 4 seconds. This is going into the formula v equals u plus at. With some rearranging, we can see that acceleration a is going to equal 2, 1. Let's move over to Newton's second law. F equals ma. F equals 2 times 2, 1. F is 4, 2. The magnitude of F, we're going to apply Pythagoras. 4 squared plus 2 squared square rooted is 2 root 5, or 4.47 newtons. In part C of the question, we've been asked to determine, in terms of t, an expression for the velocity of p. So what is your expression for the velocity of p? Velocity still comes from v equals u plus at, but we're going to use an unknown time. We're just going to use the variable t and generate an expression from there. So the initial velocity, negative 3, 1, an acceleration of 2, 1, and here's our unknown t. Our expression for velocity, negative 3 plus 2t, 1 plus t. In part D of the question, we are asked to find the time when p is moving parallel to the vector 3i plus 2j. For something to be moving parallel, its velocity is going to be a scale factor of the vector it is moving parallel to. So I'm going to start off with this expression, v equals lambda 3, 2. Let's substitute in our general expression. Let's expand out this vector, and here we have it. From here, we're going to generate two equations, negative 3 plus 2t equals 3 lambda, 1 plus t equals 2 lambda. We have two unknowns from two equations. Yes, these are simultaneous equations. Let's write those out again, and you can solve any way you want. Your equation solver on your calculator, you can do it by substitution, by elimination. Either way, we get these two results. Lambda equals 5 and t equals 9. So to answer the question, it will take 9 seconds before particle P is moving parallel to the vector 3, 2.